Kia ora Year 11 and 12. Here's another question from assignment 3. Again, this is one that's good for level 3 complex numbers. It's actually an old exam question. I'm pretty sure it was only a merit question because it's really not too tricky once you spot what to do. And it's all about the discriminant. So we have to prove that the roots of this quadratic equation are always real for all values of c, where c is real. In other words, we've got real coefficients on this thing, not complex ones. So we want to start out by explaining what we're going to do, which concerns the discriminant. So for real roots, either 1 or 2, we need b squared minus 4ac greater than or equal to 0. Now I'd be loose when I was marking this on if you'd said strictly greater, because it does say plural roots, not just one. So let's have a look at what we need. Well, we've got a equals 3, b is equal to 2c plus 1, and c is equal to, annoyingly, negative c plus 3. So these c's obviously mean completely different things, just to confuse you. B squared minus 4ac is equal to 2c plus 1 squared minus 4 times 3 times negative c plus 3. So we're going to clean that up a bit. We'll get 4c squared plus 4c plus 1 plus 12 times c plus 3, giving me this. So it's worth doing this slowly, because if you muck this up, the questions might get much harder depending on your mistake, plus it'll just be wrong. So 4c squared plus 16c plus 37. So what we need to show is that that is strictly positive. So there were several ways you could go here. Some of you went on to tell me that it would be strictly positive, and the best answer to this was to say, well, this thing here is a parabola, and if it's going to have no roots, that means it's got to be hanging up here, which means that I can go on and find the discriminant of this thing, and the discriminant of this equation will need to be negative. So that's all good if you can handle that, but there's a much easier way, and it involves your favourite thing, completing the square. We just have to show that it's positive. So let's take my first two terms, so 4c squared plus 4c, and leave the 37 outside. So completing the square on this gives me c plus 2 squared minus the bit that I've added in by mistake. So that's 4 times 2 squared. So minus 16 plus 37. And that gives me 4c plus 2 squared plus 21. Now a really nice logical argument here is to say that that must be greater than or equal to 21, right? Because this can't ever get lower than 0. And 21 is strictly greater than 0. So we know that b squared minus 4ac is greater than 0 for all values of c. Therefore, it always has real roots. So you might be wondering, well, how did she know to do completing the square? Well, it's a very useful way. If you're looking for something to be positive, if you think about it, square numbers are always positive. So it's a good strategy to use on much harder problems than this one. It's fine if you went the discriminant route with this question, but this is, I think, the cleanest and easiest way to do it. Okay, so work through it again, try and change the numbers and see what happens, and I'll be back with some more videos soon.